Thanks, Lauren. All right, so real quick, let's start by introducing me, what I do besides organize this meetup. I'm a principal engineer at Anaconda. I work with the distribution team, so most of my work is actually open source. I'm one of the core team members for Conda and Friends. So that includes Conda build, Conda locked in the installers, and I'm also a member of the Conda Forge team. So I also do a lot of Python and other language packaging. Professionally, most of my background has been in scientific and high performance computing for the life sciences, either as a system administrator, a programmer, and a couple years in grad school, which I would rather not talk about. And then I've been using Python as one of my primary programming languages for about the last 10 years. I'm obligated to say that Anaconda is hiring. We currently have 35 open positions, most of which are in engineering, but we do have a couple of sales and marketing, and I believe some content management jobs. So the link's there, and I'm happy to field any questions afterward. All right, so we're going to talk about today some general information, mostly about how Python development works. Some of the new syntactic sugar things in Python 3.10, and I'll explain what that term means. Some highlights about changes in the standard library and built-in functions, and then I'm going to touch on probably the biggest change in Python 3.10, which is the introduction of a syntactic element called structured pattern matching. Just real quick, what this talk is, it's brief, it's a highlights reel. I'm not going to go into great detail about exact use cases, about how decisions for some of these changes were made and how they're implemented. There's going to be a varying level of knowledgeability. Some of the stuff I'm familiar with, but since this came out last month, some of the things I'm still going to be learning along with the rest of everybody else here. And then I'm going to say it's slightly opinionated in that I'm just going to highlight the features and changes I personally find interesting. There may be other things that you'll want to know about. So along with that, what this talk is not, it is not a comprehensive walk through the Python 3.10 changelog. We don't want to be here all night. It's not a Python tutorial in the sense of if you're new to Python, there may be certain things you're not familiar with. I will try to, again, touch upon it, but I won't go into great detail about it. I am not talking about anything other than the reference C Python implementation. The features here may or may not make their way into PyPy, into IronPython, into a number of other Python implementations. And then most critically, I am not advocating that you upgrade to Python 3.10 now, and I'll touch upon why as we go along. All right, so some general information about this release. How do you get Python 3.10? The official installers are now available on python.org downloads, release Python 3.10. A shameless plug for our company and our ecosystem. You can conda install Python 3.10. There are a couple of bugs in both our the Anaconda packages and the Anaconda Forge packages, but it is usable for the most part. But critically, as of today, not all projects support Python 3.10. IPython, I know, doesn't quite work correctly. Numba is still not implemented in 3.10. There are probably a few other big name projects that haven't completed their transition to 3.10 yet. A quick word about the term PEP. It was mentioned in the last talk. I will mention a lot of them in this talk. The term PEP stands for Python Enhancement Proposal. It's basically the mechanism of how the community makes decisions about new features and major changes that get into C Python. PEP1 is the PEP that defines what a PEP is. It identifies them as design documents, and it should be a concise technical specification and provide the rationale for the features. And then there's sort of a meta PEP0, which is the index of PEPs that includes itself in PEP1. One big thing that has changed in the last couple of years, Python 3.10 is now the second release under PEPS 602, which is C Python's new annual release cycle. Prior to Python 3.9, new C Python releases came out every 18 months or so. With 3.9, the C Python development team has committed to releasing every 12 months and supporting the releases for every 5 years. This includes a year and a half of full bug and security fixes. And then after that year and a half, there's about 3.5 years of security fixes. And the development process is now stacked. So once the beta for 3.10 was released, it means 3.11 development has begun. I think it's a little easier to understand this release schedule graphically. The green circle at the top is where we are today, sometime in November. The gray is basically the pre-alpha stage, the red is the alpha releases, and then the yellow, oranges are the beta and the release candidates, and then green is that full 1.5 year support. So as you can see, once Python 3.9 was released last October, the alpha cycle for 3.10 started, and then it feature froze in probably May or June of this year, and 3.10 went into beta, which meant the Python 3.11 cycle started. And when 3.10 was released last month, the 3.11 went into beta, and then in about 6 months or so, we'll start the 3.12 development cycle. So what does this new schedule mean for you? The goal with this Python software foundation was to make sure we get smaller, more regular, and more predictable releases. With the 18 months timeline, there was some ambiguity, there were rushes to get features in. And so for users, the goal has been largely achieved. There's now faster access to new features. For everyone, it possibly may mean certain features get deprecated. We are still committed to 2 releases between announcements of a deprecation and the possible removal of it. But since they're shorter releases, instead of 36 months between when the feature may be removed, you're now shortened down to about 12 months. For package maintainers, and that includes people who write libraries for PyPI and then maintainers like CondaForge and Anaconda, it does mean we possibly would have to support more versions. So in the past, you would be looking at maybe 3 or 4 versions. Now you would be supporting possibly up to 5. And I would say possibly because there's discussion in certain projects about not supporting every currently available Python version. And then for this meetup, for anybody who wants to give a talk, this is a great mechanism. We're releasing every year. There's going to be one of these, and I would prefer not to give them every year. So let's move on about what's new in Python 3.10 or stuff that's changed in 3.10. First part is about syntactic sugar. For those who aren't aware, syntactic sugar is essentially a term for syntax, and I'm just going to lump features in that just basically make a programming language easier or nicer to use. It's not necessarily anything that has to deal with the lower level implementation with things like the abstract syntax tree and interpreter. It's just things that make it more user-friendly. The big one, I think, in 3.10 is we are now providing improved error message. They're more detailed, they provide more context, they provide more hints. And I think the big motivator for this is essentially for a long time, you would get things like syntax error, invalid syntax, and that's not a particularly easy thing to Google. So kind of some illustrative examples. If you drop a colon, for example, in 3.9 and below, we just say, hey, there's syntax error, point in an empty space. In 3.10, it now tells you, yeah, we expected a colon here. This is something I'm pretty sure everybody here has done at some point in their lives in using a single equals rather than double equals. Now, instead of just saying invalid syntax, it actually provides a suggestion that you mean double equals or the Walrus operator. When we won't get into that whole mess. There's more context. So if you do things like drop a parentheses, it doesn't say invalid syntax and point to a line that may or may not be actually anywhere close to where the syntax error was. In 3.10, it now says, hey, you're missing a close braces, and the kind of its partner started further up rather than saying, the next if block, for example. Attribute errors. So if you're looking for something in a module or something like that, it now offers a suggestion. If you misspell or fat finger something, for example, instead of getenv, you type getenv. It now suggests getenv. The same thing for variable names. If you fat finger your variable names, it will now offer what assumes or suggests what you might mean. One thing I did mention earlier about not immediately upgrading to 3.10, a lot of these, especially the suggestions for name and attribute errors, I do know haven't been implemented in IPython or Jupyter Notebook yet, so they'll be silently eaten. All well and good, but I will warn you there are some things that didn't quite improve. We had this at Anaconda. If you put an extra M in from for your import statement, it suggests you put a comma rather than correct the spelling of from. But all in all, still pretty good improvement. Context messages. Context managers. So the next thing I'm going to talk about are context managers. For those who aren't aware, context managers are essentially what you shove into with statements. They define a runtime context that it basically take automatic actions when you enter that block and when you exit that block. So the most common example you tend to see is with you can use the open built-in function as a context manager. So you say with open, your file name is in file, you do the read, and then once you leave that with block, your file is closed. You don't have to worry about cleanup. Speaking of SQL Alchemy, SQL Alchemy has a mechanism, for example, where you can do with session.begin. When for relational databases, it automatically starts your transaction. When you leave the block, it'll automatically either commit or roll back that transaction depending on what happens in the block. And this is, again, a feature that allows you to express your code more clearly without having to work with a lot of the minutia about especially starting and closing things and cleaning things up. So what's changed in 3.10? You now support parenthesized context managers. So in Python, you can now do things like if you can actually stack a number of context managers. And if you follow PEP8 and you want clean code, there's a tendency to try to avoid overly long lines. You can now wrap all of that in a parentheses, so you don't have to use the / literal for a line continuation. In 3.8 and below, this used to throw a syntax error, and then in 3.10, it actually works as you expect. You may have noticed I mentioned 3.8 and below and not 3.9. So what happened to the 3.9? Turns out in 3.9, one of the major changes there was a new parser in CPython. And that parser implementation sort of silently accepted parenthesized context managers. So it was basically an implementation detail that leaked into a change in the language syntax. But in 3.10, the decision was basically made to make it an official part of the language grammar. For those of you who remember the Pi 3.5 to 3.6 to 3.7 release series, this is sort of analogous to what happened in CPython with dictionaries preserving insertion order. So it turned out in 3.6 that was just a side effect of how dicts were implemented in 3.6 and the re-implementation there. And then in 3.7, it became a formal part of the language spec. Kind of some other syntactic sugar things. If you are starting to make use of type annotation and static checking in Python, Python 3.10 now overloads the OR operator for types. So instead of using the union operation, you can just basically say int or float, both as the argument type and the return type. It actually works in the is instance built in. So before you had to pass a tuple, but now you can just use OR. This one I really like. In 3.9 and below, type aliases, which is basically a way for type annotations just to map their names, were very easy to confuse with string literals because it was basically just an assignment to a string literal. In 3.10, you can now, it's not required, but you can mark it as a type alias. And there are other things in 3.10 that I'm not going to talk about that kind of improve the typing. Just note here, Python, as far as I'm aware, is still going to remain a dynamic duck type language, but this is a lot of it is building the framework for improving code quality and being able to do things like static analysis to better understand code and check for bugs. Moving on, let's talk about standard library and built-in changes. This is one that I also really like. Zip now has a strict argument to do length checking. And where this comes from is that one of the more common bugs you'll see, and it's really, really hard to catch, is when you use zip. You'll often assume that the arguments you passed are of the same length, but though previous to 310, there wasn't actually any way for the zip function to check. So if you did something like this, which I've done in my code, if you zip your keys and values to form a dict, you could accidentally, if you, for example, your key or value arrays were different length, or your key and value iterables were different length, you could accidentally truncate your dictionary or have items not appear in your dictionary. With 310, if you pass strict equals true, it will now actually throw an exception value error. It's a good way to catch these sort of things where you want to assume you want your arguments to be the same length, but you don't want to put a lot of extra code checks in there. Async, we're moving a lot more to asynchronous kind of code in Python, but there's been a lot of improvements in the asynchronous code management. There's now an A closing context manager. It's really, really useful, and because you, again, no longer have to manually go in there in your code and go close your async generators. Again, this is useful, for example, if you're expecting a lot of data over the network or something. You don't have to insert a lot of network cleanup code if you're using async network operations. Along the same lines, we now have async equivalents for iter and next. Then for a lot of the async functions prior to 310, you had to actually pass the event loop that you wanted to connect to. That is now going away. And most async functions essentially now assume you're using the event loop of the current thread. And it's going to simplify the code because you're basically not passing a bunch of context around or trying to obtain the context. Other important changes, SSL and TLS, we're slowly moving towards making the internet a safer place, at least with respect to encryption. We now basically require the only supported versions of OpenSSL 1.1.1 and the 3.0 series. The SSL module is now switching to more secure defaults. Basically, it requires forward secrecy. Some cipher suites with weak key algorithms are no longer allowed. Some cipher suites that use weak signature algorithms like MD5 and SHA-1 are no longer allowed by default. Python is now, again, supporting modern web standards, networking standards. We're dropping SSL version 3, which is ancient and known to be broken, dropping TLS 1.0 and 1.1, which is critical because things like the PCI, so the body that sets standards for credit card processing, for example, says that none of these protocols should be used. Sad news for anybody still using Internet Explorer 6 through 10, you can no longer connect to a server that runs Python, but you probably should also be connecting Internet Explorer 6 to the modern internet. For package maintainers, disutils is now deprecated. This was in PEPS 632. The decision was made because disutils is ancient. It's very, very undocumented. It's unmaintained. It will be removed from the standard library in Python 3.12, which should come out in a couple of years. And the advice is essentially, we should be moving to modern setup tools, distribution, pip, etc. And again, this is a broader shift. The Python ecosystem is starting to rethink how it does packaging, but that's going to be a talk for another time. And then kind of other random things of note, there's now a pop count if you are doing a lot of bit twiddling. If you can actually now call bit count on any integer in Python and get the number of ones. The statistics module, which is actually built in, now supports the covariance function, Pearson correlation, and very simple linear regression. This is not to say it's going to be a replacement for packages like SciPy or scikit-learn, but if you just need to do some very, very basic statistics, you now can just basically use the built-in functionality of Python 3.10. Data classes, which again, I can give a talk about at a later time, now supports keyword fields, which is kind of great because it gives you some flexibility in how you initialize those things. So last thing I want to talk about is something called structural pattern matching. Again, this is kind of the biggest change, at least in my opinion, in Python 3.10. So what's structural pattern matching? If you're familiar with C, Java, JavaScript, it's essentially switch, which hadn't existed in Python before, but with more capabilities. It's actually closer to the constructs that you have in languages like Haskell and Erlang and Scala. It introduces match and case as statements and allows you to extract information from data types, make decisions and branch on them, and then apply specific action based on different form of data. It's actually, this was actually broken down into 3 different PEPs. 634 was the technical specification, so it's the details how it's implemented. 635 was an explanation of why it was implemented and kind of the things that we noticed in the ecosystem that led to its implementation. And then 636, if you're interested in using this feature, I would definitely recommend you start by reading PEP 636. So at a fundamental level, it's essentially a replacement for sort of the if, elif, else constructs. So kind of a simple one if you're dealing, for example, with web code. If error code is a 401 or 403, do something. If it's 404, do something else. 418, make T, and then everything else just give up and panic. So that's code on the left. On the right is what that kind of structure now looks like with structured pattern matching. You match on basically the error code. You can do a case. You can use the OR operator to select between different values. And then there's a concept of the underscore, and that again matches other languages for a wildcard matching. So this also supports unpacking and capture, basically similar to things like split and a lot of the newer Python 3 features. You can unpack values into tuples or a combination of tuples and other things, and then bind them to variable names. So a common use case, is if you use stir.split, then you have to do a lot of decision making. Did you end up splitting into 1 or 2 or 3 different parts? And then based on that, what do you do? And then with match, you basically call match stir.split, and then you can do case, and then you can basically, within those case statement, bind them to variables A, B, and then you can, again, do things like splatting to and other. So in the last case, A and B would be scalar strings, and then other would essentially be a list or tuple that captures anything else. Again, this is largely syntactic sugar, but there are definitely advantages if it simplifies a lot of logic. Kind of some of the other cool things is you can mix and match literals and captured values. So again, going to stir.split, you can do things like match A, and then the second component is the Y, the literal character Y. You can bind A, if the second character in this split happens to be an A, B, or C, you can bind that to the variable B and then use that in the subsequent actions. And then one of the things to be aware of in match is order does matter. The interpreter is somewhat helpful in making sure you don't do strange things, but in this case, for example, that kind of more generic case A, B that towards the bottom, it needs to be there because cases and matches are done from the bottom, from the top down. And if you put the most generic case up, it will always capture it and stop processing. You can also do even fancier things. You can use if as what's called guard values. So you can, for example, only perform an action if a function evaluated with that variable is equal to something. And then more importantly, and this is, I think, the largest use case for this, you can match objects, right? And so you can do things like you can match a stir, you can match any stir, and then, for example, if you're doing a lot of data processing from various data sources, If it's a stir, just do the load S and then process it. If it's already been deserialized as a dict, you can actually just inspect whether it's a dict that has the key name in it and then do something with the value. Great part is, again, because you can kind of wrap and fold these in instead of, dereferencing the dict and then using key, you can just basically say immediately bind that value to the variable name. And then you can also bind to your own custom classes. So you can do things like, is this a point object? And if it is, do something with that object. But again, quick first, there is a lot more. You can match position on keyword arguments. So you can basically match kind of a half constructed object. So with points, you, for example, can say only match a point with the X coordinate at 0. I've kind of touched upon it. You can kind of nest a lot of these matching structures, and then you can match other things like enums and constants. Again, I would recommend reading PEPS 636 for a tutorial. And then PEPS 634 if you want to see all the gory details and the full details about what you can do. Just to wrap up now, a few warnings about structural pattern matching, and it's actually true. The first point is actually true for adopting anything in Python 3.10. Definitely, if you are a package maintainer or you have to deal with compatibility with a lot of older Python versions, for example, if you're sharing code with collaborators, you probably want to avoid this until everybody is caught up, just so they don't run into syntax error. As I mentioned, order does matter. Matches are made from the top down, and the first match, similar to what happens if elif structures, will stop the evaluation. This is not like C. There's not a break statement. So once you make a match, it will stop evaluation. And then there are kind of, because of how the name binding word, you will probably want to read PEP 634 or some tutorials, because there are a few weird scoping issues, especially if you use the underscore or things where you don't catch every possible match. And with that, I think I'm just going to wrap up. Leave links to my LinkedIn and GitHub, and I'm happy to take any questions. Yes, I'm glad people caught HTTP 418 as I'm a teapot.
What teapot?
Scrolling up, what about Edge? Edge does support all the modern TLS, even the version before they switched to WebKits. So, cool. Any questions?
I have many about the pattern matching thingy. It's cool. So basically, what you're showing us is something that was switched in like C languages. There wasn't ever a switch in Python. Now it's switch on steroids, because you can match things you never imagined you can match. And you notice like nested near the end. Can you say something about it? Like nested switch?
So the nesting is essentially similar to what I did here with the second case, where I'm matching a dict, and specifically a dict that contains the name key, and then I'm binding that to the variable name. So I could do, for example, that case, dict name colon name if, and I probably should have used different variable names, but like I can say if name dot starts with A, right? You can do really, really bizarre things, like with that point class. If your point class for some reason takes a dict as an argument to its constructor, you can actually do pattern matching by shoving that dict into the point constructor. And then you can do things like list of, you could do something like a list of 2 point objects. Or a dict where the value is a point object where the coordinate is 0.
It's amazing what they think about it. No wonder it took 10 years to think about it. It's not trivial.
Yeah, there was actually an older PEP. It's somewhere in the 500 series that first proposes, but it finally got implemented in 310. I did see a question: is underscore actually part of the syntax? Yeah. So for case, the underscore is specifically reserved as a wildcard. I don't actually know what, for example, what would happen if you used a wildcard, somewhere else with, well, let me take a step back to explain. So in a lot of Python code, you'll see underscore as a var name for basically something you don't care about. So for example, if you do a split and you only want the first character, you'll do a comma underscore equals something dot split. And if you did something like that and then use match in case, I'm not 100% sure because I honestly didn't try it, but I probably should.
So I'd like to ask you a question about something that you brought up
Yeah.
towards the beginning of the talk, and you said that this talk was not an endorsement to switch to Python 3.10 now.
Yeah.
Do you have any like recommendations or guidelines around how long should you wait after a version of Python gets released before you move your code over to the new one?
I would say when every library you use gets there. And then again with the 310, because of this 12-month cycle, I would start planning on you can back computer, right? So 3.9 is going to drop support in about 4 or 5 years. So if you haven't made the migration in about, I would say 2 to 3 years, I would definitely start looking. And again, because this is Python, just generally the major version 3, it's very unlikely that your 3.6, 3.7, 3.8 code is just going to stop working. Modulo a couple of certain things like disutils where they're just things that what we need to drop for various reasons. But you likely with this 12-month cycle have I would say 2 to 3.5 years before you have to consider absolutely migrating. Unless again you air gap and then your code runs and you never have to touch it again. But I think the bigger challenge is if you are a package maintainer. And so I know with, for example, NumPy, there is an ongoing discussion about with this, again, the annual release, how many versions they want to practically support. For a lot of the projects like NumPy, and we're very close at Anaconda with, for example, the number development team, because it is open source, because it's a largely volunteer effort, the idea that you can support 4 or 5 versions continually and have the CI and have the testing, I think that's going to be a challenge. And I think as a community, there's some decisions that need to be made. And I think where you're going to see that is projects like NumPy being more aggressive about how they update, and being more aggressive about the features they may start using. So for example, NumPy, I know, dropped support for 3.6 about a year before the CPython maintainers did. So if you're using a lot of libraries, I would definitely pay attention to what your critical packages and the decisions you're making around this accelerated release cycle.
Awesome, and thanks for bringing up the the issue of packages, and if you're a package maintainer, where do you invest your effort? Because that was going to be my follow-up question. You as someone who has to maintain these packages across many different versions of Python, do you have feelings about the new release cadence?
I think it's fast, and I think we're still getting our footing around it. I think it's less the release cadence and just being able to adapt. Let me bring up that slide. Where is that? Yeah, this one. I think for a lot of package maintainers, the challenge for us is essentially you don't get a lot of lead time between when that release, the major, minor, basically a 3.x release happens. So that's where that green bar starts. And once that starts, we're already having to start paying attention to what are the new features, what are the language changes in the next release, right? And not very quickly into that release cycle, you're going to have to start dealing with the next release. And I think that's the huge challenge we're going to, again, have to decide as a community, how we're going to deal with this. I think for a lot of users, it's actually not a bad thing. I think if you want to, in terms of developing the language, I think this release cadence is much better from a user perspective and a developer perspective, because again, we get features a lot faster, right? And again, one of the other critical things that changed is the previous 18-month cycle. What you end up seeing is, well, we're going to have to wait another 18 months before we even have the possibility. And a lot of times it was actually longer to get this feature in, to get this bug fix in. So in month 17, you saw a lot of scramble to get things in. It's a drain on the C Python maintainers. There's a risk of getting half-baked things in. So I think in terms of stabilizing the ecosystem, it's probably a better cadence, but it is more work for maintainers. And I think that's a balance we're just going to have to figure out how to deal with.
And so this might be a silly question, but is this something where, if more people from the community stepped up to help testing on, newer versions of Python or the version that's from, 2 years ago, is that something that would help ameliorate this issue? Or is it really about the bottleneck here is the core maintainer time, and we're just going to have to stop supporting older versions of Python more rapidly?
I think it's a little bit of both. I think testing is definitely one of them. I think the bigger thing, for example, with a lot of the development in type hinting, for example, right? For a project like NumPy, having the access to type hinting, and there were a couple other features, new changes in type hinting that I didn't mention. Type guarding is one of them, so you can write custom guard functions now. So you can say, we expect something to return a list of NumPy arrays with possibly certain features, with certain attributes. So that came in 3.10. The issue is with the accelerated release and with the possibility of having to support 5 releases at once, if this came out in 3.10, and again, backdating it, just using 3.10 as an example, as a NumPy maintainer, this is a really cool feature. Like, we would solve a lot of possible bugs if we could use this type checking or type hinting and static analysis tools. But we also have to be aware that some fraction of our user base is on 3.5, right? Or in 3.6. And so we can't implement this until 3.6 gets deprecated enough. So I think it's partly that we may start seeing a shift to some more concept of long-term support releases and more bleeding edge releases. And I'm not a member of the NumPy core team, just to be clear, so I can't speak for them. I can speak, I do know the number team. And for them, it's things like, how soon after 3.10 release can we practically get, the AST and the bytecode changes implemented? right? And how far into the 3.11 dev cycle would that put us? And so there's things like that. I know the type checking tools are, maintainers are having similar discussions about, well, if we're, again, really nice features, things we would love to have, but how do we support this with 5 active releases? We as the conda community, I mean, we've joked about we're just going to force everybody's base environment to, next time you do conda update, we're going to move you to the next Python versions. But from a PR and enterprise support perspective, that's a terrible idea. But again, things we would love to have. Like type checking and matching would make a lot of the conda code base easier to understand and easier to contribute to. But we can't use that for a while. So it's a balance. I think it's just everybody, because this PEP is a year or two old, is still trying to find we're still trying to find our footing with accelerated releases.
Awesome. That was a very, very thoughtful answer. So thank you so much for that.
Yep.
Are there other questions that people would like to ask our speaker?
All right.
So compared to 3.9, 3.9 had a lot of many small changes. The number of changes for 3.10 is approximately the same. Looking at the log, I haven't studied it, but like I'm trying to figure out how much more complexity can be done in 1 year now.
Quite a bit, actually.
Ouch.
I mean, fun part is also again, because we're now in the 3.11 dev cycle, there's actually quite a number of 3.10 and 3.11 fixes that are now too. Yeah, let me just share my. So this is again, why I'm not reading through the entire changelog. So 3.10 starts here and it goes down for quite a number of pages. It's RC2, RC1, beta 4. I mean, it's going quite a ways down.
Whoa.
I mean, 3.11, by the way, here's the 3.11 fixes that are coming out. Where is that? So it's still quite a bit of changes that are already in 3.11.
How many people are working on those generally? Just give us an idea, ballpark. 10, 20, 50, 100?
I don't actually know how big the core team is these days. Dylan,
I know 2 people from the core team.
Yeah.
Personally.
Yeah. Interestingly, the now retired BDFL is Guido and Rossum has apparently come out of retirement. He actually made some contributions to 3.10, and at least one to 3.11. So he's still a core developer. I know a couple of the longtime maintainers are still there. I would imagine it's in the tens as the core team and probably a few hundred contributors. Yeah. By the way, in case you're not aware, I believe Guido van Rossum is now working for Microsoft doing Python development at Microsoft. He's just not the BDFL, so he's not one of the major decision maker, and that's really that's the major change that's happened in the governance structure.
Yeah, it's good. It's good. It's a good thing. Everyone's quiet. I think it's time to wake them up. Maybe say something on the record that is will wake them up. Yeah.
Any more questions in the chat?
Yeah, Collier had a good link there about what they were doing, working on Microsoft. They are trying to work another project to make a faster C Python implementation or Python implementation. Any insight on where Python? Yeah. So setup.py is slowly going away. I should probably actually get someone to talk about this. There are a number of kind of pretty big changes in the way Python does packaging. Wheels are becoming a big thing. There's a move away from sort of the setup. Actually, weirdly, we just deprecated disutils, and the future of setup tools and setup.py in particular is ambiguous, I would say. There's a move towards basically packaging and PyProject.toml and some of the other ways of expressing dependency information. But yeah. Yes, there is quite a bit of change in the way that Python packaging, and this is not speaking as a conda maintainer, but just Python packaging in general is changing. And I will, or we should rope someone into giving a talk about that.
Well, you just say it's on record.
Yeah.
It was recorded. We'll hold you to it this year.
Yeah.
Next year, I mean.
And if, by the way, if anybody wants to learn, I'll say that again and repeat what I mentioned very early on in the talk. You know, one of the reasons we run this meetup is also especially for people who aren't as comfortable giving public presentations. This is sort of a very, very low pressure venue, and big benefit of annual release cycles is you are pretty much guaranteed to need at least one of this every year. So speaking as part of the organizing committee for our meetup, we would love for people to volunteer. And you know when it's going to be. It's going to be in November of every year.
Cheng, do you know if the governance now is effectively by people that are hired by big tech?
It's a governance council. I don't think everybody works for the big companies, but don't hold me to that. I don't actually know who's on there.
Guido was there for at least last year. I'm not sure if they even how fast they rotate, but like he's probably still there.
Yeah, Barry Warsaw's on there. I don't know who else is currently on there.
I recently came under the realization that the Linux Foundation is effectively controlled by big tech in the US and China. I didn't think that was the case until I dove in and started getting into meetings.
Yeah. Yeah. I wonder if I can get Peter or Travis to give a talk about how Python governance works now.
Should be a doubt.
Yeah.
Yeah, that'll be very interesting to hear who's driving the direction now effectively.
Yeah, that'll be fun to see Peter again. I haven't seen him around this community in a while, so that should be fun.
Yep.
You met him a year and a half ago. Approximately a year and a half ago, you met him in person. Actually, it's a year ago you met him.
Yeah, but I'm talking about the community itself. Like we haven't seen Peter in a while.
Well, he started this. He's now busy. We're holding it for him. He'll come back. Don't worry.
Yeah.
You send him an email, he'll come. It's like he answers emails. So
yeah, I know. When we have our disputes, he might get into it.
Yeah. Actually, if I'm talking about it, Cheng, do you have something interesting in Anaconda that's really new, other than like new projects or something that you can talk about that? Because like I know that you have all those like Holovis project that's part of you, and you have Number and lots of other things. Is there any new projects that you have in Anaconda now?
We just hired 2 of the Piston core developers. So Piston is another attempt at making a faster Python interpreter. Let me see. Like again, I'm going to try to rope them to giving a talk at some point. They're based in New York and Germany, but and they're slowly moving towards a production ESC release. What else are we doing at Anaconda that I can talk about? We are making the conda solver faster. We're working with the Mamba development team to roll all that code into conda itself. And that should be coming out early next year or being announced early next year. What else? Oh,
All of this team rolled up Lumen this year, but next
Yeah.
year they're doing something big, or as far as you know. Actually, I'll ask James Bednar.
yeah.
I'll let him not bother you.
Yep. There's a bunch of interesting stuff there. We're doing some work, and Condaforge has done some work too on Python and the new Mac, the Mac M1. And we're trying to get some benchmark and performance numbers. Yes, not anything that we're working specifically on at Anaconda, but I think there's also ARM is going to be a bigger, spitballing here. ARM is going to be a bigger player with the move that Apple has made. NVIDIA just announced an ARM plus CUDA product today or yesterday. So I think Python on heterogeneous compute is kind of an interesting development, especially for any of the numerical or machine learning stuff.
Isn't it like Intel moving to more like an ARM-like architecture that's on their own? That's kind of what I heard. Like they're trying to kind of move away from the current architecture to something a little more like ARM-like.
They're not moving to ARM in terms of the instruction set. It's still an
no, something ARM-like, but not.
But what is their most recent release? Their most recent CPUs, at least for I believe desktop and laptops, are tracking what ARM is doing with what's called the big little architecture. So you have the big cores are basically your high performance but high power draw cores. And then next to them, you have a set of little cores, which are kind of the lower power. You lose some performance, but they're much better at power usage. And so I know the M1 has that, right? It has 4 big, 4 little, and I think and Intel's most recent release, something like is also similar to that. Alder Lake, that's what it is.
All right, any more questions? If not, I'm gonna stop the recording. Questions? All right, well, thank you so much, Cheng. That was a great tour of Python 2.10. That was very helpful. Thank you so much. Awesome.